By 2050, researchers estimate that there will be more plastic in the ocean than fish. Despite our best efforts, only 9% of all plastic we use winds up being recycled, and that it can take anywhere from 500 to 5,000 years to fully break down. Plastic is cheap, durable, adaptable, and it's everywhere. But the good news is there's something else that's cheap, durable, adaptable, and everywhere. And it may even be able to help us with our plastic pollution problem. I'm talking about bacteria. Researchers estimate that there are roughly 5 million trillion bacteria on the planet, live everywhere, in all sorts of diverse and extreme environments. And as such, they have to get pretty creative with their food sources. So, after noticing this, and after learning about all of the creative ways that bacteria find food, I started to think, could bacteria in plastic-polluted environments have figured out how to use plastic for food? In my hometown alone, there are 7 EPA-designated Superfund sites. These are sites that are so polluted that the government has deemed their cleanup a national priority. So, I decided to trek around to these sites and collect soil samples teeming with bacteria. What I was trying to cook up was a carbon-free media, or a food-free environment. An environment without the usual carbons or food that bacteria need to live. So in this environment, I would provide my bacteria with the sole food source, PET plastic. PET plastic is the most widely produced plastic in the world. It's used in all sorts of food and drink containers, with the most notorious example being plastic water bottles. So, what I would be doing is essentially putting my bacteria on a forced diet of PET plastic and saying which, if any, might survive or hopefully thrive. These bacteria had figured out how to eat PET plastic. Just as we humans digest carbon or food into chunks of sugar that we then use for energy, so too do my bacteria. My bacteria, however, have figured out how to do this digestion process to big, tough, durable PET plastic. My bacteria have a special enzyme called a lipase that binds to big, tough, durable PET plastic and helps break it into small chunks of sugar. So basically, PET plastic goes from being a big, tough, long-lasting pollutant to a tasty meal for my bacteria. While reducing, reusing, and recycling are important, they alone are not going to be enough to solve this problem. Plastic-eating bacteria is not a cure-all, but given the current statistics, it's clear that we humans, we could use a little help with this problem. Bacteria might be a really important part of the solution.